Hello, everyone. I'm Rob Mason, and along with my partner Vinder, we are going to present to you our analysis of COVID-19 vaccine sentiment. So our objective with this project was to look at Twitter data about COVID-19 vaccines and to use sentiment analysis to classify users' perspectives as positive, negative, or neutral. By doing this, we hope to gauge public opinion on the different vaccines and vaccination in general. The reason we care about this is because if public opinion on the vaccines are generally positive, we anticipate that would correlate with more people trying to get vaccinated and motivate those who are skeptical or afraid of getting vaccinated to sign up so we can safely end the pandemic. On the other hand, if we discover that sentiment toward the vaccines are generally negative, we can use this information to try to find out why that is the case so we can better understand people's concerns on why they maybe don't want to be vaccinated and how we can change that outlook. So we first approached this problem by building a Twitter scraper in Python, which we use to collect tweets over a 7 to 10 day period to compile a data set of over 12,000 tweets. In addition to those tweets we gathered, we also obtained a Kaggle data set on vaccines that contained over 50,000 tweets. Here we created word clouds for both data sets so that we can visualize some of the terms that appear most commonly in each one. On the left side of the page is a word cloud created from the data set we obtained from Kaggle, which is a little bit older and wasn't updated as recently as the one we collected ourselves. Here we see Moderna and Pfizer, some of the larger words, and they're familiar to us because they're two of the vaccines which are being widely distributed in the US and in our area. We ran some statistics on this and found that about 15% of the tweets in this data set included the term Moderna and about 23% included Pfizer. We also might note that we don't really see anything about the Johnson & Johnson vaccine here, despite the fact it's one of the three that we might be most familiar with. We also see stuff about other vaccines here. We see AstraZeneca, which is one of the vaccines being used more widely in Europe. Covaxin is one being used in India. We also see the word India over there, which might be because they've been having a big surge in COVID cases and deaths over there recently. On the right-hand side of the page, we see our word cloud for the data set that we collected, and this being much more recent data, we see a large difference. So the largest word that we see right here in the center is Johnson, and one of the other words that appears fairly large is blood clot. We also see some of the other ones like Pfizer and AstraZeneca again, but not as high of a proportion as we did in the first data set. So after the news about the J&J pause, that vaccine went from barely being talked about in the first data set to the most talked about in the recent one. Right here is just a screenshot of our Jupyter notebook on how we cleaned and processed our tweets. We really took a simple process here. After we read them in, we just used a preprocessor and removed any duplicate tweets. Some other characters like slash, some punctuation we took out, and then we dropped any tweets that were empty after cleaning. Next, we used 3 different online libraries to classify our tweets from both our data sets. We used TextBlob, NLTK Vader, and the Stanza Sentiment Analyzer. If we look at the charts on the right-hand portion of this slide, we can see our sentiment results for both TextBlob and NLTK on the Kaggle data set. As we can see, the results for these two methods were fairly similar, with over 80% of the tweets falling into the neutral or positive categories according to our classifiers. Here we can see a side-by-side comparison of all 3 of the classifiers. On the left are the TextBlob and NLTK analyzers that we just looked at, and on the right is the Stanza Sentiment Analyzer, which we notice is significantly more skewed towards the negative than the other 2. We then did a composite sentiment analysis based on all 3 classifiers together. And here's just an example of the code we used to find an average sentiment score of the 3 classifiers for our tweets. We also used a voting technique to determine sentiment as well, which I'll talk about more on the next slide. So for the average, we did it exactly as it sounds. We just added up the scores given to each tweet by all 3 classifiers and then divided that by 3. That score was then weighted against certain thresholds for positive, negative, and neutral and classified accordingly. We can see how this changed a lot of the neutral values received when using each of the methods individually into either the positive or negative categories. With a max voting technique, it took the individual category determined from each library as a vote for positive, negative, or neutral, and then classified each tweet as whichever category had the most votes. So for example, if one tweet got classified as positive by TextBlob and NLTK and neutral by the Stans analyzer, it was determined to be positive because it was 2 votes to 1 for positive. In the case of a tie vote where a tweet returned a different answer from all 3 of the classifiers, so one said positive, one said neutral, and one said negative, it just defaulted to a neutral classification. And if we look at the corresponding graph over here, we can see that 54.9% of the tweets fell into that neutral category. And while this may make it seem like there were a lot of tie votes, it's more likely that most of the votes were actually voted to be neutral, because over 44% of the tweets were classified as neutral by the 3 classifiers when they voted individually. So it's likely that all of these were neutral tweets, or a large majority of them were neutral tweets that were voted to be neutral rather than a tie between all 3 of the methods. Here we can take a look at the same 2 methods when employed on the recent data set. If we recall earlier, when viewing the word cloud for this newer data set, we saw Johnson and blood clot were 2 of the larger words. So we might have expected these tweets would be slightly more negative overall than those in the last 2 graphs. However, that doesn't seem to be the case. If we first look at the average sentiment analyzer on the left, we see that the recent data has about the same percentage of positive tweets as the older data, and only about 4% of the tweets shifted from the neutral to the negative category. So maybe some of those people who were on the fence about getting vaccinated have shifted to the negative side after the Johnson & Johnson news. However, there's not really a drastic change in sentiment. The max voting method saw a drop of about 6% in the neutral category, but an even increase in both the positive and negative classifications. So it seems these changes might not be significant enough for us to determine if the J&J pause had a real impact. They could be caused by more people moving from a neutral standpoint to a positive or negative stance as time goes on and more information comes out. Some things we can improve upon if we were to continue work on this project in the future would be to gather a large number of tweets for our sample, because getting a bigger sample size always helps when we're doing this kind of analysis. It might also be interesting to investigate if there's a significant difference in tweet sentiment based on location. This is particularly intriguing because we know that different states and countries have different processes for distributing and administering the vaccines. So I'd be curious to see if there's an increase in positive tweets that correlated with the efficiency of local governments to get their populations vaccinated. As we know, doing any kind of sentiment analysis does come with some limitations. Even some of the best sentiment analyzers only come in with about 80% certainty. One way that we might be able to improve our results on this would be to list out some of the most commonly used words within our tweets and observe if they are used in positive or negative ways. Then we can go back to adjust the weights in our libraries and more accurately classify things. Furthermore, some of the work we have done here could have real world implications if we took it further. If we were able to look more closely at specific tweets within each classification, we may be able to identify why certain groups have more positive or negative attitudes towards the COVID vaccines. This information could then be utilized to target and ease any concerns people may have about being vaccinated. And that's all I have for you today. So on behalf of my partner Ravinder, I'd like to say thank you for watching, and I hope you enjoyed the presentation. If you have any questions or comments, feel free to contact me, and have a good one.